Have you ever gazed up at the night sky, at the myriad of stars, nebulae, and cosmic structures, and felt a strange sense of resonance, a feeling that this vast, evolving structure echoes something equally complex and mysterious, something intimately familiar? For millennia, philosophers and scientists alike have searched for unifying principles that connect the smallest particles to the largest cosmic structures. And in this episode of Stellar Stories, we're diving into one of the most provocative and visually compelling comparisons: the idea that the universe, in its grand organization and dynamic activity, might bear an uncanny resemblance to the human brain. From the delicate, filamentary tendrils of the cosmic web stretching across billions of light years to the densely interconnected network of nearly 100 billion neurons firing within our skulls, the structural parallels are undeniable. But could these similarities be more than just a superficial visual trick? Could the fundamental ways in which these complex systems organize, evolve, and process information hint at deeper, underlying principles governing reality itself? Join us as we delve into this fascinating, and at times highly speculative, analogy of the universe as a brain. We'll explore the structural and dynamical parallels, insights from network science and complexity theory, and the mind-bending implications of the computational universe hypothesis and the holographic principle. Finally, we'll venture into deep philosophical waters surrounding the nature of reality and the emergence of consciousness within this cosmic framework. So, if that's your thing, stay tuned. Before we continue, let me briefly say this is a tiny channel, and every interaction from you helps immensely. So please let me know your thoughts in the comments, and I'll reply. Our journey begins at the largest observable scales, with the very fabric of the cosmos, the cosmic web. For decades, astronomers have relied on powerful telescopes like Hubble and the James Webb Space Telescope, as well as advanced computer simulations, to map the universe's vast structure. What we've uncovered is a breathtaking truth. The galaxies we see are not scattered randomly throughout space. Instead, they form a colossal, interconnected structure that stretches across billions of light years, woven together by the invisible threads of dark matter and shaped by the fundamental forces that govern the universe. Imagine a giant web. The strands are long, thin filaments made up of galaxies, stretching over hundreds of millions of light years. They act as highways along which galaxies move, merging and evolving over cosmic time. At the intersections of these filaments are the dense nodes, the massive galaxy clusters, which contain thousands of individual galaxies bound together by the gravity of dark matter. Between these filaments and clusters, we find vast, nearly empty spaces called cosmic voids, some of which are so large that it would take a beam of light hundreds of millions of years to cross them. But how did this astonishing structure come to be? To answer that, we have to journey back to the early universe, just moments after the Big Bang. In the first fraction of a second, the universe underwent an event called cosmic inflation. During inflation, quantum fluctuations, tiny variations in the density of matter, were stretched across space. These tiny, almost imperceptible fluctuations laid the foundation for the large-scale structure of the universe. Over time, gravity began to amplify these tiny fluctuations, creating regions of higher and lower density. This process initiated the formation of the cosmic web. As time passed, gravity continued to pull matter together, and the cosmic web began to take shape. Galaxies formed along these filaments, drawn together by the unseen forces of dark matter. Dark matter, despite being invisible and undetectable by conventional means, is the key to the structure of the cosmic web. It interacts with gravity, but doesn't emit, absorb, or reflect light. Without dark matter, the galaxies in the cosmic web would not have the necessary gravitational anchors to form such long strands and clusters. But dark matter isn't the only force at work. There's another mysterious player in this cosmic drama: dark energy. Dark energy is an even more enigmatic force that permeates space and accelerates the expansion of the universe. While dark matter pulls galaxies together, dark energy forces them apart, stretching the cosmic web over time. As the universe continues to expand, these forces constantly reshape the structure of the cosmic web, with galaxies slowly moving along the filaments, merging and creating ever larger structures. As galaxies move along the cosmic filaments, they interact with one another in a process known as galaxy mergers. These mergers play a key role in the evolution of large-scale cosmic structures, and, over billions of years, galaxies will continue to collide and merge, creating larger and more complex structures. This ongoing evolution of the cosmic web is not static. It's a dynamic, ever-changing network, driven by the interaction of dark matter, dark energy, and gravity. The more we explore the cosmic web, the more we begin to see striking parallels to another complex system, the human brain. Just as galaxies are interconnected along vast cosmic filaments, so too are neurons connected in an intricate network through synapses. It's a dynamic, interconnected system where each galaxy plays a role in the grand design, much like the individual neurons in a brain, contributing to the larger function. We're observing a highly organized and intricate structure that emerged from the chaos of the early universe. Now, let's shift our focus inward to the most complex and enigmatic structure we know of. The human brain, enclosed within the skull, is a universe of its own, a network of approximately 86 billion neurons, each a specialized cell capable of processing, storing, and transmitting information. These neurons are the fundamental building blocks of thought, memory, and consciousness, forming the biological substrate for everything we experience and understand. These neurons are far from isolated. They communicate with one another through trillions of connections known as synapses. A single neuron can be connected to thousands of other neurons, forming a vast, highly intricate network. These connections are not random, rather they are organized into circuits, with each region of the brain specialized for particular functions: sensation, movement, memory, decision-making, and more. Just as galaxies in the cosmic web are organized into clusters, neurons in the brain form dense clusters and circuits that work in tandem. These circuits are highly specialized, and each plays a critical role in different cognitive processes. The neurons within these clusters form an intricate network of information processing that ensures the brain functions as a whole, seamlessly integrating inputs from our senses and coordinating the vast range of activities that make up human consciousness. At the heart of this neural network is synaptic plasticity, the ability of synapses to strengthen or weaken over time based on experience. This process, which is fundamental to learning and memory, enables the brain to adapt and change in response to new information. It's like the brain is constantly evolving and reconfiguring itself, much like how galaxies are constantly shifting and merging in the cosmic web. The connection between these neurons is not just about transmitting electrical signals. Each synapse serves as a point of communication where neurotransmitters, chemical messengers, are released to pass information between neurons. This intricate web of electrical impulses and complex chemical signals forms the foundation of our mental landscape. In the same way, gravitational forces and dark matter serve as the framework for the structure of the universe. In the brain, learning and adaptation are driven by the ability of neurons to reconfigure their connections. Just as galaxies merge and evolve within the cosmic web, neurons rewire themselves in response to experiences, creating new pathways and reinforcing old ones. This dynamic, ever-changing process of reorganization allows the brain to continually refine its information processing, just as the cosmic web is constantly evolving as galaxies move along its filaments. The similarities between these two networks go beyond appearance. They are encoded in the very mathematics that govern them. Network science, a field that studies complex networks across various domains, has found that both the neural network and the cosmic web exhibit small world properties, meaning that despite their immense scale, any point in the network is only a few connections away from another. This efficiency in connectivity is a hallmark of highly optimized systems. Studies have shown that both the brain and the universe share similar clustering coefficients, meaning their nodes, whether neurons or galaxies, tend to form dense interconnected clusters. Additionally, both systems display power law distributions, where a small number of nodes, like highly connected neurons or massive galaxy clusters, serve as crucial hubs. These similarities hint at fundamental organizing principles that transcend scale and domain, potentially governed by deep mathematical laws of complexity. Could this suggest that the universe itself functions like a vast information processing system? Some theories, such as the computational universe hypothesis, propose that the cosmos operates as an immense, evolving network of information flow, a concept that challenges our very understanding of reality. As we've seen, the structural and dynamical parallels between the cosmic web and neural networks raise intriguing possibilities. What if these similarities go beyond mere analogy? Could they point toward a deeper, more fundamental reality, where information is the very essence of the cosmos? One of the most radical ideas emerging from modern theoretical physics is the computational universe hypothesis. This hypothesis proposes that the universe, at its core, is a vast information processing system. Rather than thinking of the laws of physics as merely describing the universe, we might instead view them as algorithms, rules that govern the flow and manipulation of information at all scales, from the tiniest quantum particles to the largest cosmic structures. This isn't to suggest that the universe is like a traditional computer running on a silicon chip. Rather, the universe may function as a vast quantum computational system where information is continuously processed and transformed. In this view, everything in the cosmos, matter, energy, space, and time, could be seen as the manifestation of underlying information interacting through quantum processes. One of the key concepts that challenges our understanding of reality is the holographic principle. This idea, first proposed in the context of black hole thermodynamics by physicists Gerard 't Hooft and Leonard Susskind, suggests that the entire three-dimensional universe we experience could be a projection of information encoded on a two-dimensional surface. Imagine it like a hologram, a three-dimensional image created from two-dimensional data. In this sense, the universe itself could be the product of information encoded at the boundary of the cosmos. This may sound bizarre, but the holographic principle is a real hypothesis. If all the information in our three-dimensional universe can be encoded in two dimensions, it suggests that space, time, and matter are not the primary constituents of reality. Instead, information may be the most fundamental substance of the universe. The holographic principle also has connections to the computational universe hypothesis. In both ideas, the universe operates as a complex information processing system. Just as a computer runs programs based on input data and instructions, the universe could be continuously processing information in a way that governs the behavior of everything within it. The fabric of reality might emerge from these information exchanges: space, time, gravity, even consciousness, emerging from a deep computational process we are only beginning to understand. In quantum computing, information is processed using quantum bits, or qubits, which exist in multiple states at once, a phenomenon known as superposition. This allows quantum computers to process vast amounts of information simultaneously. Could the universe itself be operating similarly, processing multiple realities and possibilities at once? Perhaps quantum mechanics, with its probabilistic nature, reflects this deeper, more universal computational framework. Returning to our analogy, if the universe is a vast computational system, its information processing architecture might resemble the highly efficient, interconnected neural networks in our brains. Neural networks process vast amounts of information simultaneously, adaptively optimizing their connections over time. In a similar way, the universe might be continually processing, adapting, and evolving its structures in response to its fundamental informational laws. This raises fascinating questions about the nature of our reality. Could the entire universe be a form of cosmic computation, with the universe itself processing information in ways we can't yet comprehend? And could the complex structures we see in the cosmos, from galaxies to neural networks, be a product of the underlying computational processes that govern this grand informational landscape? The holographic principle, computational universe hypothesis, and quantum mechanics suggest a universe that is far more intricate and interconnected than we ever imagined. These ideas offer a vision of reality as a computational, information-based phenomenon, a perspective that could one day transform our understanding of physics, consciousness, and the very nature of existence. As we venture deeper into these speculative ideas, we are led to one of the most profound and mysterious questions in science and philosophy: what is consciousness? And could the universe itself, this vast interconnected system of information, be conscious in some form? If the universe operates as a vast computational network where information flows and processes continuously, could consciousness be an inherent property of that system? This brings us to the realm of panpsychism, the idea that consciousness is not something that arises solely in brains, but is a fundamental feature of the universe itself. In its most radical form, panpsychism proposes that even the most basic building blocks of matter, such as subatomic particles, could possess a rudimentary form of consciousness or experience. Some interpretations suggest that consciousness, like gravity or electromagnetism, might be a universal property. This could exist on a spectrum, from the simplest quantum interactions to the most complex systems, such as human minds, and potentially even the entire cosmos. This notion challenges our traditional view that consciousness is confined to the human brain or other highly complex biological systems. What if consciousness were woven into the very fabric of the universe, emerging from the intricate connections and interactions between particles, fields, and even galaxies, just as the brain's conscious experience arises from the vast interconnectivity of neurons? Could the universe, with its sprawling network of galaxies and cosmic structures, be manifesting a kind of cosmic consciousness? One theory that attempts to bridge the gap between the brain and the cosmos is integrated information theory, or IIT, developed by neuroscientist Giulio Tononi. IIT proposes that consciousness is a product of integrated information, the degree to which different parts of a system work together in a unified way. The more integrated the information, the more conscious the system becomes. At its core, IIT argues that consciousness is not just the sum of a system's parts, but the result of how well those parts are connected and how much they integrate information. Could the universe, in its vast interconnectedness, have a form of cosmic, integrated information, however different it may be from human consciousness? What if the entire cosmos, through its vast web of galaxies, dark matter, and gravitational forces, carries a form of integrated information that could be viewed as a cosmic mind, a fundamental consciousness that we cannot yet fully perceive? While IIT is mostly applied to the human brain, its core principles could be extrapolated to the universe. Could the universe, as an information processing system, possess some form of integrated information that gives rise to an emergent, albeit non-biological kind of consciousness? Some speculative theories suggest that this cosmic consciousness would not be aware in the same way we are, but could be a kind of substrate from which individual consciousness arises, similar to how individual neurons contribute to the overall consciousness of the brain. But the concept of a cosmic mind also forces us to reconsider the very nature of reality itself. If the holographic principle holds true, and our universe is a projection of information from a two-dimensional boundary, then what does this mean for our understanding of space and time? Could consciousness too be a projection of deeper, fundamental informational processes encoded at the boundary of the cosmos? The holographic principle suggests that the three-dimensional universe we perceive may be an illusion, with the true nature of reality lying beyond the confines of our perceptions. This shifts our perception of reality itself. If information is fundamental, and if the universe's structure is built upon the efficient processing of information, then could the very nature of our existence be a manifestation of informational patterns and consciousness at a cosmic scale? Might our individual consciousnesses be part of a larger, universal consciousness, like neurons in a vast cosmic brain? These speculative reflections raise profound philosophical questions. If the universe is an information processing system with a form of cosmic consciousness, could it be self-aware in ways we can't yet comprehend? Is the universe thinking or learning, evolving through the flow and interaction of information across its vast structure? The analogy between the brain and the universe invites us to think beyond traditional scientific boundaries. It hints at a universe that is far more interconnected and possibly even conscious than we ever imagined. As we continue to explore these ideas, one thing becomes clear. The more we learn about the cosmos, the more we realize that we are all part of a vast, intricate, and interconnected system, perhaps even a cosmic mind processing the universe's fundamental information. I really hope you liked the latest stellar story. Please remember to like and subscribe. See you next time. Thanks so much for watching. If you've gotten this far, at least I had the respect for you to wait until the main show was over before I shamelessly promote my book. It's called The Flaxen Tyranny. Here's the gist of it. The sentient starship Echo vanished on a mission to colonize a new world. Now he's back, but Earth is on its knees. A brutal alien empire, the Flaxens, are mercilessly exterminating humanity. A colossal metallic cylinder casts an ominous shadow over Jupiter, controlled by an enigmatic AI, and the solar system teeters on the brink of collapse. Captain Kip Eastcott and the crew of Echo must unravel the mysteries of a forgotten past and fight for a future they may never see. But their greatest threat could be the one they trust the most. Cyrilda, a captivating young woman raised in a Flaxen concentration camp with a dangerous secret that could destroy them all. Can they defy time, tyranny, and treachery, or will humanity fall to the Flaxens? The Flaxen Tyranny, now available on Audible, Kindle, and in print. Details in the description below.